Good morning, it's Professor Elliott once again, and we're going to look at the three basic types of circuits we're going to encounter. First one will be a series circuit, and then a parallel circuit, and then a combination of the two. So, series circuit, the characteristics of a series circuit are that there's only a single path. I'm just going to continue to use electron flow. In class, we'll flip back and forth between the two, but anyway, okay, that's going to be the current flow like that. Notice that the current flows through each of the three resistors, which is acting as the loads, and it's all the same current. Okay, so we can make this statement that current I1, that's the current, flowing through resistor R1, is this equal to same as the current I2 equals the current I3 equals current. Kind of run out of slide space here. IT, which should be the current either returning to or exiting from the battery. Okay, the voltage, each resistor load will have a voltage across it, and the sum of the three voltage drops will add up to be the source. Okay, so here's the key characteristics. The total current is the same as the current through load 1, 2, 3, 4, 5, and so on. Source voltage E, this is Kirchhoff's voltage law. It says that V1 plus V2 plus V3, or the sum of the voltage drops across the load, must always equal to the source. The total resistance is equal to the sum of resistances 1, 2, and 3. Okay, not doing any calculations in this presentation, just some basic identifying key characteristics. Parallel circuit. Parallel circuit, the loads are connected in parallel or across one another. So that would mean then if battery, I like my 12 volts, if that would be a 12 volt battery, that would mean that V1 is 12, V2 is 12, and V3 is 12. Okay, this would be current IT, current leaving the battery. This would be current I1 flowing through R1. This would be current I2 flowing through R2, and this would be current I3 flowing through R3. These two current would continue. This would be I3 again. This would be I2. This would be I1, which recombines to form IT. Key characteristics. IT is the sum of the branch currents, I1 plus I2 plus I3 plus I4. E is V1 equals V2 equals V3 equals V4. All the voltages are the same, and that's the formula for the total resistance. Okay, in the real world, most circuits are a combination of series parallel. For example, in your house, you might have receptacles. Okay, receptacles are all in parallel with one another, so each receptacle has the same voltage, and the receptacles are then connected to the power panel. If you have a light, you have a switch in series with the light, but that circuit is in parallel with other circuits, so it all has the same voltage. So most real-world circuits have elements which are in series and other elements which are in parallel. So a series parallel circuit is oftentimes referred to as a complex circuit, and that's the abbreviation, short form for circuit, CCT. Okay, so don't worry about the values here at all. We'll be dealing with these circuits starting in week 6. Yeah, week 6, and we have lots of time to solve those circuits. But anyway, so this time I'm going to go with conventional flow just for fun. So this here would be your total current IT. Okay, this would be current I1. Perhaps, hopefully, you can see that I1 and IT are actually the same current. Okay, so that would be IT, and that would be I1. Okay, and then current flows down like that. That would be I2, and that would be I3, and that would be squeeze it in here, I4. So in actual fact, I1, I2, and I1, IT, and I4 are all, that's IT coming back, are all the same current. So the current leaves, right? So this R1, R4 are in series with the battery, and then the current splits R2 and R3. So these R2 and R3 are in parallel. R1 and 4 are in series, and this is a basic series parallel circuit. Okay. Don't worry about the math today. Just if you can follow the current flow, that will be good enough for today. Okay, great. Thanks for listening. See you next time.